Thanks for joining us. It's the BS and Beer KC discussion group getting together today with Bryan Uhler, Ben Bogie, and Ken Nelson, as well as Joe Cook and Rob Wadsack from Fine Home Building. As usual, we appreciate Fine Home Building and Green Building Advisor working with us on this. It's really nice to still be able to get together, even though it's virtual, to have these discussions and basically just to continue to share ideas and keep everybody sharp, or hopefully getting sharper. So I'm Travis Brungart. I, along with my partner, Joe Cook, they're on your screen, run Catalyst Construction here in Kansas City. And then with a third friend of ours, Joe Nichols of Thrive Building Solutions, we run the discussion group here in Kansas City. And if you're not familiar with the Midwest Building Science Symposium, that event is still coming September 16th. It's going to be kind of an all-day seminar with Steve Basic and Jake Bruton presenting the 4 control layers. Huber's involved, Fine Home Building's involved. We got some great sponsors, and it's at Boulevard Beer here in Kansas City. So it's going to include free beer, and if that doesn't get you in town for that thing, I don't know what will. So watch your inboxes for that. That's what's coming up. Today, though, we have a great privilege to have another all-star cast. We got great people coming to tell you things that you may already know, and so we can have a good discussion, or things that you don't know, like me. I was excited to see this article from Bryan Uhler in my JLC magazine back in June, talking about a simple ventilation strategy. And although I do carry a master mechanical license, I am perpetually dumbfounded with how much I don't know about how these systems work best together. And because I feel like a lot of times we're a little bit slow in the Midwest to pick up on some of the Northeastern codes, or in Bryan's case, the Pacific Northwest. I feel like we have a lot of builders in this area that could really benefit from these strategies. So I reached out to Bryan, and he was kind enough to join us. If you would like to say a little bit about yourself, Bryan, please introduce yourself. Tell us a little bit about Pioneer Builders, and we can get going.
Sure. So my dad started the company in 1978, and my background is actually, in college, was finance and accounting, but I've worked with the family business, for years, always been around it. I'm not a building science expert by training by any stretch of the imagination. I think I've kind of stumbled into building science because of how many problems we've had over the years. I think our company motto is we've done everything wrong at least once. Sometimes we've done things wrong multiple times. And generally we have fixed them in the past, but understanding why there was the failure, over time, just that body of knowledge goes up. So we are a high performance spec builder. And so I think we just have a little bit of a different focus, because dollars and cents is a huge part of the puzzle for us to try to find that sweet spot, which is why I'm super excited to have Ben here. He has way more experience than me with especially high-end technical stuff. So I think there's a couple of different ends of the market that can be covered. So there's your intro about me.
Thanks, Bryan. Yeah, that's a great lead into Ben as well. Of course, Ben Bogie, currently up north, soon to be slightly less up north. Tell us, Ben, what's going on?
Slightly. So I'm Ben Bogie. I'm a second-generation high-performance builder, currently working as production manager for Colbert Building in Portland, Maine. I grew up in this. My dad was doing super insulated and passive solar from the late 70s, early 80s, so I've kind of had it drilled into me since day one. And my work ranges from cutting-edge, net zero, high-performance passive house to historical preservation work on 18th century buildings. So my career's kind of been all over the place. Currently reside in Portland, and recently made the decision to return closer to family back in Connecticut in the next year. So exciting stuff coming.
That's awesome.
And personally, I nerd out on ventilation because it's one of those areas that we still don't know a whole heck of a lot about, and things are progressing rapidly, and we're figuring stuff out, and research is coming out all the time. So it's kind of a moving target.
For sure. Yeah, that's a great lead into Ken. Ken Nelson is with us from Panasonic. And since Bryan referenced the Panasonic equipment in his article, we were fortunate to be able to get with Ken and have him on tonight. How are you doing, Ken?
I'm good. I just got my microphone and speakers configured just in time.
It's awfully nice of you to take the time to do this.
No, I enjoy these. These are fun.
Good deal. Can you tell us a little bit about yourself and how you got into the indoor air quality portion of what Panasonic's doing?
Well, I came to Panasonic, the ventilation group, from the electrical side. I was with a company for 15 years before this, doing electrical testing, training, and so forth. And then came over to ventilation as just basically as a people manager. But I kind of got rolled into like a lot of the low income weatherization program coming in right in around the R at the time of the ARA funding, and so I was exposed early on into weatherization projects and what IAQ means to low income multifamily projects. So from there, it just became an exercise in understanding the science and then trying to figure out how to apply it into a price point, if you will, and create this value living or living value, if you will, for people. So at Panasonic, I'm not only have I had the ventilation group for 13 years, I also had the heating and air conditioning group for 2 years. And now I'm kind of segueing into the building science component of it, as well as doing all the ERVs and product management for ERVs and whatnot. So there's a lot going on at Panasonic. And as one of the more senior team members, it seems like I've got a lot of stuff going on. So it's fun.
That's great. That's an excellent pedigree and a really good foundation for what we're going to be talking about today. So I really appreciate you taking the time to join us.
Yeah, appreciate having me.
I didn't want to skip over Rob and Joe. You guys should definitely get a better introduction than I gave you. You want to tell us what's going on, Rob?
Well, I'm just here because, at Fine Home Building, we try to facilitate people learning about this stuff by bringing the people who actually know what they're talking about and do all this stuff day to day. So I'm glad to be in on the conversation, but pretty much I'm going to let all these smart guys do all the talking.
That's my move. What do you think, Joe? You got anything to add before we go to Brian's presentation?
Yeah, I'm excited to hear it. It is pretty much my move to sit back and listen and try to take it in.
Right on. Well, Bryan was kind enough to prepare some comments on this, and I don't know how deep you want to dive, but I'm hoping that the way that we've done this in the past, certainly for our live discussion group, we try to kind of bring everyone up to a baseline understanding. So if you're super expert in this and it seems a little rudimentary at first, Bryan's just trying to dumb it down for me. And then you guys can really go deep with Bryan and Ben and Ken after that. Is that fair, Bryan?
Actually, I was going to try to make it as technical as possible, which means really dumb. So that's great. Yeah, no, I can just get going.
Hold on one second. I think it might be worth mentioning, I don't know if you got this, Travis, that to use the chat box down below if you have any running questions during the conversation. You can click that chat box. Just make sure it says all panelists and attendees in the to section, and fire away any questions or comments in there. And I'll shut up now.
Yeah, thanks,
Thank
Ben.
you, Ben.
That's actually, that should have been my job. But yeah, basically, we'll just, unless there's a place where Bryan feels like it's a good stopping point in the middle of this presentation, we'll just hold questions till the end or try to answer some of them in the chat box as we go. But let's leave it to Bryan to figure that out.
So first, I just wanted to begin. If you've ever wondered what Princess Leia and a stormtrooper, if they had a child, what would that child look like? You're looking at him. Yeah, so I've got the headset on because I have 3 children, and hopefully that'll help concentrate a little bit here. Well, let me share my screen for those who are seeing this visually. And I'll just show you a couple of pictures from a house that I just visited recently. Our electrician got a hold of me and said, hey, I've got some friends, they've got some problems. You're into air stuff. Do you know anybody who could take a look? And let me just make sure. You guys, yeah, it looks like you're seeing the screen. I can't see the chat box the way this is, so I'm kind of flying solo. So what I did is I said, well, I can't make any promises, not saying that, you know, I know everything about this, but I would be happy to take a look. The child's been sick, the mother's been sick, the father just got pneumonia for the first time over the winter. So we poked around a little bit, got up in the attic, and pretty quickly we saw this situation here. Thank goodness they had one of their bathroom exhaust fans running. So I could hear it, but I couldn't see it. And so we took this insulation, pulled it away, and you can see that the discharge of that fan was never ducted to the outside. The home was probably built 1986-ish, and so it was taking all of that moist air and dumping it into the insulation, the fibrous insulation there. That insulation on the bottom of it had some sort of a vapor retarder, whether it was craft paper or what have you, I couldn't tell you for sure. So that was one problem. Then another problem was it was a passively ventilated attic, but this vapor barriered insulation was shoved all the way into the eaves. So there was no source of air to run up and ventilate that attic. Truthfully, if the attic eaves had been open, it probably would have been something that they could have gotten away with in our climate. But they didn't. As with so many cases, it's not just one thing, but it's a combination of factors that leads to a failure. But I think this illustrates well that there's two components to maintaining good indoor air quality. The first that we often think about is maybe humidity. We put exhaust hoods over our ranges, so particulate matter. But if you look here, the structure, let me just poke through a couple of pictures, it doesn't appear that the structure was actually affected. But that is another component. So we might say occupant behavior, or rather the health of the occupants, and then also making sure that our structures remain sound. I'll just click through a few more of these. You can see that should be the membrane underneath there. Turns out there was two of these. At some point up here in the attic, we've had mice. So again, you're getting into that idea of indoor air quality. I think another thing that's interesting about this home is it wasn't forced air. Everything was resistance heat, with the exception of a mini split that they've got installed. This is from the crawl space. Due to the conductivity of this metal, I have no doubt that that's what led to, you can't see it in the picture, but there was sponginess in the subfloor that they got repaired. You can see the copper running through here. Probably built to code at the time, but it is what it is. Another thing, they've put their fan right over the toilet. My least favorite term in construction is fart fan. And that is what we have called it in our company for many, many years. It's an exhaust fan, so it's not over the shower. So yes, it's important. We're all adults here to exhaust the smells that happen in a bathroom. But if we call it an exhaust fan, I think it captures the purpose of the fan better than just human smell. This is one of the filters from the mini split. The gentleman let me know that they are keeping them cleaned. Well, not particularly. So this is one of, should have been two filters, but on the top side of that is sort of what I would call the return air or the supply air for these ductless units. That too has to be cleaned. So that was one of the points I wanted to cover. Was Brent Hull talks about celebrating maintenance. I could not agree more with him. We have to know what it takes to maintain these units. You can see the dirtiness here at the bottom, but we also have to teach the occupant how to try to maintain and keep their homes healthy. At the end of the day, it is up to them. But can we do our part in trying to help them have a healthy life? That might be the last one. Yep. Okay, so I'll stop sharing my screen. should I pause for a minute or just keep on going, Travis? I believe you're muted.
Operator error. Sorry, man. I think we've only got a couple of questions in the chat that don't necessarily pertain to what you've shared so far. I'd say go ahead and keep rolling with the other presentation about your ventilation strategies moving forward.
Okay, sounds good. Figure it's better to pause and be told to stop your yapping and give you that opportunity.
I think Ben will wave his hands furiously if he sees something.
I couldn't see him. Yeah, that's the problem. I was staring at a screen with nothing, but there's his beautiful face. Okay, so let me run through this presentation a little bit. One thing I'd like to cover first is this is the strategy we use. If you have any kind of a background in structural engineering, you design the house to withstand the anticipated load. And so in our area, it's design category D2, seismic design category D2. That basically means that at some point they're anticipating an earthquake due to a variety of factors. I'm actually more geared thinking in terms of structural engineering than some of these other things, but the principles for engineering apply equally. It's really a matter of just taking physics and applying them to the built environment. So the way we have to build our foundations here are likely going to be different than Ben or Travis or Joe. Well, Ken's in my neck of the woods, so he's probably in the same design category. So to come up with a one-size-fits-all is an inefficient engineering design solution. But you have to take that within reason. So certain climate zones, you can probably build a certain way, but it even gets down to the site, how you build. If you've got a basement, if you've decided to place your mechanicals in a certain location. So what I'm about to go through works for us at Pioneer Builders. If we get into the more mechanical side of things, we've got this beautiful air conditioning system called the Pacific Ocean, pretty close to us. So what does that mean? It means that generally the currents are going to come down from Alaska. And that's great for cooling. So we're in climate zone 4C. That's going to be different than somebody in Florida where the ocean currents are going to be coming down from the equator hitting the eastern seaboard. So again, it's not just a one-size-fits-all. We happen to also live close to the Olympic Mountains, but we're on the leeward side. There are so many microclimates in Washington, you couldn't believe it. So even knowing really on the almost micro level, the site, the region, the climate, the weather patterns, granted, like Ben and I have talked about, appears that they're changing. You want to think about that. But the idea again is don't just take what you read or what you hear from a podcast and say, okay, I'm going to apply that to this home, modify it and make it work. So now that I've gotten that out of the way, to talk a little bit about ventilation. It's hard for us because we can't see it. Christoph Irwin always talks about that we're living in a fishbowl. We happen to live in a fluid, but we just can't see it. So fish, they live in a bowl. This is our bowl, the fluid that surrounds us. And if you've ever had or seen a hot tub and you put a lid on that hot tub and you just leave it alone, 6 months you open the top, what happens? It is filthy, it stinks, all sorts of bad things have grown because it's not being filtered and cleaned out. So what happens to us as humans if we don't breathe in clean, fresh air? It's not good. For us, the air is going to come in, it's going to hit our lungs, it's going to transfer with our blood. Blood goes everywhere, the way our neurological system can function. We generally think of health in terms of the food that we take in. Are we sleeping enough? Are we exercising? Are we getting our heart to pump? Well, I did a Google search, and as we all know, everything you look at Google is true. But how many times a day do we breathe is what I looked up. And it came up with a range. So just to keep it simple, let's just say that we inhale and exhale 20,000 times a day. That seems almost unbelievable. So I did just some quick math to back check it to say, is that even somewhat in the realm? It is. So I think that impresses on me the importance of making sure where I live, what's coming into my nose and out is healthy and clean. So let me just look down here a little bit. Okay, another thing just to comment on, air is a transport medium. So you think about water. I think I like talking about water because it's something that's so tangible. So water has various components to it, constituent parts, right? If you go to the Pacific Ocean, there's salinity in there. If you go to a lake, it's not going to be a saltwater lake. But if you went to the Dead Sea, my dad's been there, you can literally just lay in there and float. It's got a high saline content. And so it's the same thing with our air. There's different components, particulate matter, but it's also a good transport medium for moisture. And just, again, to dovetail back to that illustration, with just as water can have more salt or less salt, air can have more moisture or less moisture. So the way we do our homes, and this is going to be a little bit of a recitation from the JLC article, we discharge spot ventilation from our bathrooms and utility room. We do the same thing with a ventilation hood over our ranges. You can duct those with a recovery ventilator, an enthalpy recovery ventilator, energy. Ben's saying no, I can see him out of the corner of my eye. You can do it. I'm not saying you should do it. An HRV, which will transfer sensible heat, but not latent energy, latent heat. The moisture is not going to transfer from the ingoing to the outcoming streams and vice versa. In the Pacific Northwest, our primary building science issue that we solve for is bulk water. It's rain. It's not relative humidity from the outside. We're not in Florida, where we've got to deal with huge amounts of moisture load from the outside in vapor form. We deal with liquid water. So for here, we want to take our wet rooms and get rid of that water. And so what we do is we've got, this is the value engineering side, the Whisper value fan. It's pretty inexpensive, but the modules that we get added on are just killer. So we set our relative humidity sensors to 50%. They were actually running. We're at our hottest time of the year right now. So on the house that we're building, one of them that we're building right now, it was running. So that tells me when I go in the house, okay, we're at 50% RH or higher. I could change the dial if I wanted to. We turn them down to 50 CFM, pretty stable, not spending a whole lot of energy on that. We only have to deal with high relative humidity at certain times of the year. We're dominated by heat in here, even though we're climate zone 4C, a temperate climate. Because of that, and because we're a spec builder, buying a separate dehumidification doesn't make sense for us, because our heating and cooling side, we've got mini splits all throughout the house. One of them, the one I just mentioned, it's got 2 heads and 2 ducted units. I took one of the units today. Daikin has a dehumidification mode. So I took it off of AC, put it on dehum, and it, I think what it does is it takes the ductless unit and gets it super cold to try to condense the water. And then it discharges it out of the condensation line. Is it an energy penalty? Generally, a dehumidification unit costs less to run than using an air conditioning unit. However, we're using VRF systems, and so I don't think in our area that it's enough for us to matter. So that's where we are getting rid of a lot of our air that we feel is bad. We get our houses to somewhere between 1 and 3 ACH 50. So to go back to that fish bowl, if you poke a hole in it and you poke a hole for supply, you can keep that filled up if you're supplying the air by getting rid of some of that air or the water or the fluid. So what we do for fresh air makeup, because you think about it, we're going to be turning those fans on either manually or it's automatically going to come on every time somebody showers. If you run your dryer, you're going to be pulling air out of the house, depending on if it's ducted or not. Cooking, yes, ours is 400 CFM, but realistically, I don't know that people are going to be running them as often, and it comes down to much of this in terms of rates, how long something actually runs. And we've got a vacuum system in this home, so we might not think about that, but it is literally vacuuming out of the house. All of that stuff is piped out. So because of that, we don't want to negatively pressurize the home, and we want to supply fresh air. So we've got the ERV, and one question that came in on Instagram is, what's best practice to have a separate ducted ERV system or integrate it into your duct system? I think the answer is an unequivocal, it's best to have it separate. But one of my second least favorite terms in construction is what's best practice. I hate that term. I think it is such a subjective term that can lead into a comparison of, well, if that's best, then that's what I should be striving for. Well, I know a Lamborghini and a Porsche is better than my Toyota Sienna. But I got 3 kids, and I think the Toyota Sienna is a pretty decent car. It's best for me. But it is not built as well as the Ferrari or the Porsche down the street. So what we do, again, this is not the best way to do it in a duct design perspective, and I recognize that. We duct the ERV supply air into the return air of one of our ducted systems and utilize the duct distribution system for that air. And it works for us. The house that we're doing right now is so compact and so small up there, and it is so chopped up that to try to get supply air into each of the rooms and get return, I mean, if you walk this house, it's almost impracticable to do it that way. So let me just run through here. Dehumidification, I think we kind of covered that. I guess the last thing I would comment on, in terms of callbacks, we typically build with solid hardwood oak in pretty much the great room kitchen areas of our homes. And so we try to keep things at homeostasis within reason. And so in the wintertime here, the outside has lower RH, it's colder. We will get gaps in our hardwood. In the winter, the gaps will close up. We might even get some cupping. So by doing the ERV, the intent is to temper some of that outgoing air, I should say incoming air in the winter, with some moisture, so that in the winter we don't get our RH too low. And in the summer, it's the converse. Because we're air conditioning the entire house, the inside should be a little bit less RH. And so instead of just taking a bunch of moisture-laden air from the outside, it'll be tempered a little bit and come into this space a little bit lower relative humidity. That's it.
That's a solid start, Brian. You've got a bunch of questions rolling through the chat box, but I also want to give Ken and Ben an opportunity to get in the mix here, because I know that there's Ken, I know that Ken's got the technical covered, but Ben, you are so ready. I can tell you're about to pop. Just go.
Okay, so I've been kind of clicking together a couple of bullet points here of things that I think are crucial information to go over. So the first thing is how do we decide how much air we need for the house? So currently code is based off of ASHRAE 62-2, and depending on which code cycle you're in, it varies the rate a little bit. Like I said before at the beginning of this, there's still a lot of research that's going on around ventilation. So it is still a moving target, and the codes have been shifting through the past couple of cycles. But currently it's based off of occupant number in the house and square footage. I think 2015 was 1% of floor area is 1 CFM. So if you have a 1,000 square foot house, you need 10 CFM for a 1,000 square foot house, plus 7.5 CFM per occupant in the house. And I don't want to get mired into the numbers here, because you can go into your IRC and you can pull this stuff up for yourself. So that's a good starting point. There's varying ideas on whether or not that's too much air or not enough air. You have to kind of do your own research in that area if you want to stray away from code and decide that you need to do something different. As far as where we distribute that air to, we spend 1/3 of our life laying in bed. 8 hours a day, hopefully 8 hours a day, something like that. So that's 1/3 of your life is spent in bed. So I'm of the school of thought that I want to deliver as much of the air as possible into the bedrooms. Because if you put an indoor air quality monitor in a house room by room and you watch the levels, you'll see that 1 o'clock in the morning, 2 o'clock in the morning, depending on your schedule, you see a huge spike in CO2 in people's bedrooms. And that's, number one, it causes you to wake up tired. It has adverse health effects, asthma, bronchial issues, lethargy, muscle stuff, you go down that rabbit hole. So I want to deliver as much air as possible into the bedrooms, because that's where we're going to be spending the bulk of our time while we're in the house. Second, I want to exhaust from sources. So like Bryan was talking about, we want to pull stuff away from our range hoods, number one, and then our humidity producing areas. So our bathrooms generally. If you have an indoor sauna, hot tub, whatever, you want to manage those areas particularly well as part of your strategy. So supply to your bedrooms and suck from the places where you're getting moisture from. There's 4 types of ventilation systems. So we have, well, maybe 5. There's supply-only ventilation. These are commonly the products called air cyclers that people use. And what these do is, depending on how it's set up, it supplies untempered outside air into the return side of your ducted system in your house, your air handler, and then it's distributed throughout the house that way. Usually kicks on the blower motor and the air handler to cycle the air throughout the house. Problems with that is that generally they're unfiltered. There's no energy recovery, so you can be dumping either super dry or super moist air into the building. It can also run into issues with Bryan was talking a little bit before about the dehu settings on mini splits. The way that you achieve dehumidification in mini splits, from my understanding, is essentially you amp the compressor up to make the coils really cold, and you drop the airflow across those coils. And what it does is it causes the coils to get super cold and condense the moisture out of the air. So if you're dumping untempered air in across your coil doesn't get cold enough to actually pull moisture out of the air. So supply only, that's type 1. The second type is exhaust only. I prefer this. I'm kind of going in order of, worst to best here. So exhaust only. You can do this strictly by getting yourself bath fans. Panasonic's and a lot of the other ones now have an ASHRAE 62-2 switch on them, timer on them. You can set them to run 20 minutes on, 40 minutes off, whatever the code prescribes for your area. And what that's going to do is it's going to pull the air out of the house. The problem with that is, again, you don't know where that air is coming from. It could be dry air, it could be humid air, it's unfiltered air, it could be being filtered through mouse poop and old insulation and whatever else. So that's the second type. Next type, and preferred over those two, is balanced ventilation with no recovery. So basically what you're going to do in this case is you're going to take supply only and exhaust only, and you're going to combine them. So I've done a system. This is actually my mom's house. When I built a house for my mom, she was on a budget. We did balanced ventilation with no recovery. There's a blower from Air King that brings air into the house, distributes it throughout the house, and then the range hood over her stove runs continuously. So there's always a constant flow of air. So it's always supplying air and it's exhausting air. That system in particular has the ability that you can set thresholds for humidity and temperature. So when it gets really, really cold or really, really humid, it'll actually stop that incoming air so you don't run into condensation issues or comfort issues throughout the house. Not a perfect system, but a step above the other two. Next on the list, moving our way up, is going to be heat recovery ventilators. So what a heat recovery ventilator does is it's balanced ventilation, generally filtered, and it exchanges that heat from the outgoing and the incoming air streams, or that cool, depending on whatever season you're in. But physically, it's exchanging heat. You can't exchange cool. So it exchanges those, so there's less of an energy loss. That's what we call sensible heat. So that's what Bryan was talking about earlier, if you're not familiar with that term. So the sensible heat is what we perceive as temperature around us. So it's exchanging that sensible energy. So you're getting filtered air and you're losing less of the heat or cooling that you're trying to keep inside of your building. Next step up from that is an energy recovery ventilator or an enthalpy recovery ventilator. And what that does is the same thing as an HRV, but it also exchanges a level or a portion of the humidity from that airstream. So during the winter months, in a cold climate like ours, where it's particularly dry outside, you don't want to be bringing a lot of dry air into the house. You want to try and keep the moisture in the building. It tries to keep a portion of that into the building so that it's returning in the incoming airstream. And it's the opposite in summer. You're trying to discharge that humidity to outside. So those are kind of your echelon of ventilation types. The next thing we need to pay attention to is commissioning. So what commissioning is actually making sure that the things that we've installed are doing what they're supposed to do. So Bryan put up a post on Instagram earlier today that he had some, Whisper selects that weren't actually flowing because it looked like the painter had painted the louvers closed on the exit. It's classic. It happens. Or you find out that it's, blowing into the attic because somebody forgot to tape an elbow or something like that. We need to make sure that what we're installing is actually working. Personally, on our projects, I have the good fortune of owning a flow hood or a bolometer. It's not something that everybody has, but if you reach out to a decent HVAC company, generally they'll have one. And what this does is this allows us to actually measure at the registers or at the discharges on our ventilation system and measure how many CFM are flowing out of that. You can do what you think is a great job installing your ventilation equipment and find out that it's not doing what it's supposed to be doing. And I know this firsthand. I've learned some hard lessons, and I'll tell you one thing. Generally, when you think it's like, it's rated for 100 CFM, it's pushing 100 CFM, it's not pushing anywhere near that. Just a quick sidebar here. We did a downdraft range hood, downdraft range exhaust on a project with an 1100 CFM blower. This blower is completely hard piped, perfect installation, like textbook. When I measured it at the wall cap coming out the wall, it was moving about 230 CFM, 1100 CFM blower, and a good quality blower. So we need to test. I'm not saying that we have to get everything absolutely perfect, but if we're not testing, we don't know what's going on and we can't make any adjustments to it. The next step beyond commissioning is if you have the ability, is to do monitoring in your buildings. We bought a cheap FUBA air quality monitor. We've kind of stepped up from that since, but what we did is we stuck the FUBA into a client's completed house just to kind of watch what's going on in the bedrooms. Are we seeing spikes in CO2 at night? Are we seeing high humidity levels? It's just another way of us ensuring that these systems we're installing are actually working. And we don't, we left it with them for about 6 months and then we went and took it out of there and we can put it onto another job. So it's kind of a cheap investment. It's, I kind of consider it due diligence for making sure that we're installing good systems that are working properly. Makeup air. I saw a question about this pop up in there. If you're building buildings that are reaching any semblance of air tightness, we need to be supplying makeup air, number one, for range hoods. I know the code says that it's above 400 CFM. I think we should be supplying, first off, I think 400 CFM is far inadequate for actually ventilating the byproducts of cooking. But if even at 400 CFM or below, I think we need to be supplying makeup air if we have a reasonably tight envelope, because like I said before, you can have that 400 CFM blower and it's not getting any airflow to be able to be exhausted. So we do, regardless of what it is, we do dedicated makeup air. The parts to do it is about $100. If anybody has any questions about the technicals, reach out to me on social media or get a hold of Travis or any of these guys. And I'd be happy to share with you what I figured out over the years. It's about $100 to work in makeup air on a project. I really think we need to be supplying makeup air, definitely with hoods. And if you're building really tight houses, you should probably also be supplying makeup air for dryers, because a dryer can be moving several hundred CFM out of your building. And we learned this the hard way because we had clients saying that, hey, our dryer is taking forever to dry the clothes. We went through all sorts of rounds of repairs with the appliance company and troubleshooting and all that. And what we discovered is it just wasn't getting enough airflow because the building was so tight in order to exhaust that humidity out of the line to be able to dry the clothes. So that's my rant. Trying to keep it short.
I appreciate that, Ben. You got a lot in there, and I'm sure you're going to get a deluge of questions through the chat to circle back to that. But I do want to bring Ken into the fold here because he's been very patiently waiting, and I feel like he has a tremendous amount to add to the conversation. Ken, do you want to fact check anything on these guys, or are we pretty right on so far?
Well, no, I think everything we've said so far is spot on. There's a couple things that I will add, though, that when I'm looking at or working with builders, there's two components that I look at. One is moisture management, and the other one's indoor air quality. And quite frankly, I separate them, right? Here's the thing with moisture management. If you don't do a moisture management strategy in your house, and I talk to people about this all the time, I can take, with indoor air quality, it might take 20, 30 years to kill your occupant, right? It's a benzene, formaldehyde, all this stuff that goes through the bloodstream. You know, it's a process that begins to degrade. With moisture management, mold and mildew, I can take a world-class athlete. I could take a guy from the Olympics today, and I could kill him in 90 days with mold and mildew. With chronic pneumonia, acute pneumonia, with SARS, you know, all of this stuff, all of that can happen very fast. I had my daughter when she was 20 years old at the University of Washington. She was living in this piece of crap apartment with no ventilation. And within 3 weeks, she had chronic pneumonia. I mean, it was literally that fast. And so moisture management, you know, I always start the day when I go to a project, that's the first thing I'm looking for, moisture management, because that's the one that'll take out your occupant fast. Then we start in with the indoor air quality. Which is the secondary items like blowing mold and mildew up into your attic space, which Bryan showed with that example. And I'm sad to say that there are so many examples of that. And that house, I think Bryan had mentioned, was built in 1986. I was at my sister-in-law's house in Florida that was built less than 2 years ago. And we're talking a very nice property on the water. And they literally didn't duct the fans. They simply put the fans in and ran the insulation over the top of it so that the air was blowing straight into the insulation on top of it with no ducting. I mean, it's a painful exercise to see. And you have to be conscious of what happens with a lot of builders. And Bryan, of course, doesn't fit into this ballpark, but a lot of builders, you know, when you send a guy up into the rafters to do your ducting, that's usually the lowest paid, skinniest guy on your job. I mean, guys like me who are, you know, over that 200-pound club and 60 years old with new body parts, we're not on the rafters, right? We're not up there bouncing around. But so I've got one of the youngest employees up there chasing things around, and we get that disconnect in skill sets. And Ben had talked about a fan that had no airflow. I had a project in Bend, Oregon. These ladies owned this beautiful house in Bend, Oregon, and they were frustrated because they couldn't get the fog off their mirror. And so, I mean, and I don't know how they got my number, but so we upsized the fan. Fine, okay, I'll send you a bigger fan. It was like a 200 CFM, and no, it didn't work. They wanted more. I got them a 300 CFM fan for my little garage inventory, if you will. And they still couldn't get the fog off the mirror. So finally, I drive up there, and I'm trying to figure this thing out. I too have a bolometer. I put my bolometer on there. That thing is just moving air like nobody's business. There's no reason it was an interior wall. The mirror was on an interior wall. There's no reason there should be any moisture accumulating on that wall. And then we closed the door, and these ladies had put a door sweep on their bathroom door, a rubber door sweep that essentially shut off all of the airflow into the bathroom. So So there was no air coming in to get out. You know, as a fan guy, the first thing I always look for is duct obstruction. But in this particular case, the ducting was just fine, but the obstruction was on the supplier, right, on the supplier side. So there's two sides to every fan, right, inbound and outbound, and we have to manage that as Ben had talked about as well. So let's jump back to moisture management. And that's why when I first met with Bryan, we talked long and hard about these automated triggers. The challenge with all of these are all upsell products, right? I mean, you know, if you want to build the lowest priced product as a builder, you would probably not be putting an automated trigger because it's going to cost an extra $20. However, as a builder, I will tell you that I can put an automated trigger in there and you won't hear a phone call coming back from your occupant for the next 3 years saying I've got moisture on my windows, right? Because that automated trigger will help manage that moisture in a really aggressive way, right? Any sort of moisture, because people seldom understand where moisture comes from, right? So there's a number of places that were obvious, right? I take a shower, I know I've got moisture there. I go in and boil water on that kitchen stove, I've got moisture there. If I don't turn that fan on, that moisture still migrates throughout the house. In new construction, if you build your house, you've got essentially 100,000 pounds of lumber that comes in kiln dried to 19%. Over the next 2 to 3 years, that's going to dry to 12%, right? So now you got 100,000 pounds of lumber with 7% water, right? So that's about 7,000 pounds of water that's going somewhere. Water is going to move from wet to dry. So in the summertime, it'll move out, but in the wintertime, it's going to move in. It's going to look for that dry. It's going to move from wet to dry. So all that water has the potential, and I always talk about the potential because there's, you know, it's physics. So we cannot find, as human beings, we would be hard pressed to go find everything that affects the physics of moisture or vapor movement within a house, right? Bryan talked about microclimates here in the Northwest. There's literally microclimates in your house, right? I send 2 kids up to play in a media room. I've got a microclimate up there where their body temperatures are exuding heat, but I might have a room down here with no heat. And now I've got this desperate difference in temperature between the 2 places. Moisture is going to react differently within those. Bryan talked about how much we breathe. We breathe 6 liters of air per minute. And when that breath leaves our body at 98.6 degrees, as it leaves your mouth, it's essentially at about 100% humidity at 98.6 degrees. It's going to diffuse into the air. And we talk about this in bedrooms all the time. I talk about we'll lose or outgas about 1% of our body weight in water in 8 hours of sleep. 1%. So people ask me how much moisture is going to move through the house. You know what? How much does every occupant in your house weigh, right? What's the total number of weight? So if you have 500 pounds and you move 1%, that's 5 pounds. That's 5 pounds of water. It's almost 3/4 of a gallon of water. You might as well be sitting there with a sprayer, spraying that all over the room, right? Looking for a cold spot on the wall, like a 2x6, you know, where the 2x6 passes through, or a top plate where insulation may have slipped on the top plate. All that water does, all it cares about is finding a space to condense or condensate, if you will. And water is vigilant. It's always looking. It's always moving from high pressure to low. We have a hard time stopping that. So the way we do that is, of course, we create that low pressure system, whether it's with a bathroom fan or we do a ERV, so it's balanced throughout the house. All that is good. But we want to help that water find its path out, or that vapor, if you will, find its path out of the house. So we create that low pressure system by turning on a continuous run fan. So moisture management for you as a builder is probably one of the best reasons for you to buy an automated trigger fan. Bryan talked about putting his triggers at 50% RH. I tend to like around 70%. In fact, I have the factory now shipping at 70% RH. Because here's the thing about water. It's only a problem when it condensates, right? Vapor in the air is not an issue until it condensates. When I put the fan in the ceiling, I'm going to diminish, or I'm going to diminish the amount of insulation. That'll be the biggest conductor of energy, whether it's cold energy or warm energy, up there. So it's going to always trigger faster than, let's say, I put a condensation sensor on a wall. especially on an interior wall, it's always gonna trigger faster at the ceiling. So if I set that at 70% at the ceiling, I guarantee you I'm probably triggering faster than a 50% on an interior wall. So that's part of my particular presentation to builders, to protect their houses that they're building and not have to, take in calls that I've got moisture coming down a window or whatever. When it comes to continuous run or IAQ, I tend to be a low is slow guy, right? I want it to be continuous, not so much intermittent. And the problem that we run into with intermittent for your occupants is that if it's 2 a.m. and the bear next to you is not sleeping well, what they hear is they don't hear a continuous sound, they hear the change of sound, right? So it's that change of sound that's going to be problematic. And if they know that change of sound is going to happen again in 20 minutes, you're going to get that big elbow to say, that thing's, I'm awake and this thing's making noise. So continuous low and slow I think is always better because it's more predictable, if you will. And I think I talked to Bryan about my motto. I want ventilation to be predictable and uneventful, right? I don't want to have the wind blow. I don't want to have a temperature difference. I just want it to occur. So predictable and uneventful is how we want our ventilation to go. So I like continuous run rather than intermittent style. The other component about intermittent is if the house sells from homeowner A to homeowner B, then they have to figure out the intermittent component. So the thing about IAQ is it's about the people, right? IAQ is about people. So we did a project in Boise, Idaho, and when Energy Out West was out there, and we had 2 1,200 square foot houses, right? One 1,200 square foot house had an elderly man living there, and these were all like right next to one another. The other 1,200 square foot house had 9 people living there. So the air requirement for both of those was significantly different. So we were able to give the same strategy, the same tools in each property, but we could set them differently so that they could be scalable one direction or another. And that helps later on when occupant B moves in there and they have a different scenario. I want to be able to scale that whole process. And then Ben had talked about balanced and tempered ventilation, ERVs, and I'm a huge supporter right now of ERVs. Exhaust only is probably the lowest cost strategy for you as a builder. If you're a builder, that's the lowest cost strategy. But from an occupant standpoint, if I were a builder soliciting business to an occupant, I'm going to talk about balanced right now, right? Because we're in the middle of this pandemic, and I swear to you, a year ago, this would never have crossed my mind. But today, and if you look at the ASHRAE paper on infectious diseases, the number one thing they call for is more air change, right? We have to be able to spool up air change. So come wintertime, we're not going to be able to do a supply only because I can't dump 35-degree air into a house without tempering that air. I have to have a tempered strategy, but honestly, with the ERVs and whatnot we have today, you can spin those up and get more airflow. They're ridiculously quiet. And with the COVID issue, there's 2 components that we want to address. One is the viral load, and one is the occupant's ability to tolerate, infection or whatever. But that viral load, the only way for us as professional, air people or builders to manage that is by air change. So if we can manage, again, a predictable but uneventful air change strategy and make sure that our customers are aware of that, that gives us great value over the house down the road where they can't say that. They can't explain that. They're going to have to say, and by the way, if you get COVID quarantine, they're going to send you home and say, open all your windows, right? I mean, that's what the doctors are going to say, open all your windows. Even then, I struggle with that as a strategy because air only moves when you have a pressure differential. So if there's no pressure differential, you can open all your windows all day long, 70 degrees outside, 70 degrees inside, nothing moves. So we want to have this mechanical, we want to have a predictable air exchange. And if you're COVID positive, you can't get enough. So to keep that managed, that's the way to go. And as for you as builders, I would really want to make sure that you're having that discussion with your potential buyers about how to protect themselves and their families. And quite frankly, infectious diseases like influenza, even measles or chickenpox or whatever, all of those apply under that thing. It's just those typically don't kill you so much, right? So yeah. So there's a lot going on there. Having said that, I don't even know where I am anymore, but you guys throw something in here now and maybe we can talk about it. But I've said my piece. Moisture management, indoor air quality, air change per hour should be predictable and uneventful. I like it to be tempered. Oh, I'm sorry. Let me jump back to one more thing that Ben talked about. Bringing air and putting it into the cold air return, okay? One of the things about air conditioning, whether it's ductless or gas furnaces or whatever, you want to look at your delta, the delta of the air temperature coming in. You don't want to put more than a 30-degree delta either direction into your heater box. And you certainly, so a ductless heat pump can manage up to about a 30-degree delta coming into the condenser area. So that's another reason to use that ERV as part of that pathway. And I saw one of the questions was, where do you take up your exhaust air? Where do you pull that exhaust air out of the house? And honestly, common spaces are certainly the ones that come to mind most, but it doesn't really matter, because what happens is once you create a high pressure system in one area, it's going to move to the low pressure system. And I know for a lot of builders who are trying to really build a value property, I've done a lot with our little Whisper Comfort. Our little Whisper Comfort is 10, 20, 30, 40 CFM. And we put that in the media room or the great room because remember, IAQ is for people, moisture management is for the building. So I put that in the media room, and then I'll pick up the difference of airflow with a continuous run fan in the back bathroom. And now what I've done is I've diluted that air coming into that great room space where the occupants are going to be. And when it comes to location, I always ask the builder, so where do you see the big screen TV going? Because that's where I'm going to put this, because that's where everyone's going to dogpile in on Sunday afternoon and watch whatever game. So I put the fresh air supply in the media room by the big screen TV. I can do a small exhaust strategy, because remember, ASHRAE only counts air in or air out, not about net airflow. It's air in or air out. So if I put 30 CFM out at that Whisper Comfort in the great room, and I do 30 CFM out at the bathroom, I've got a net out of 60 CFM. I'm going to wind up drawing 30 CFM through cracks and crevices. I'll give you that. Generally, it'll always come through the front door. If you think in terms of what the most utilized door is, it's going to be the front door. So those seals will probably allow the most air. It's a very reasonable price strategy. It got some filtration. That Merv 6 on that Whisper Comfort is equal to what the DOE says the structure of the house is. That's Merv 6. I get a little pushback every now and then from guys who are telling me, oh no, my house is 1 air change per hour. Yeah, I don't have enough air to come in. And I'm like, if I have a 1 air change house and it's 1,000 square feet with an 8-foot ceiling, that's 8,000 cubic feet. So if I have 1 air change per hour, that's a potential for 8,000 cubic feet per hour. 30 CFM is only, 3 times 6, what is that? 100 or 1,800 CFM. It's just not that much, right? So it doesn't even ripple the pond of potential, if you will, in that airflow. All right, you guys, throw questions out.
It's something that I just wanted to jump in on, and I think is particularly relevant right now that you brought up, Ken, with the whole COVID thing. I flipped on the radio yesterday as I was doing a dump run, and NPR, I literally, as I turn it on, I hear them talking about air changes per hour. So, ventilation has been this, really fringe, siloed thing that, some of us paid attention to, but it really is getting a lot of traction right now. And I hate that it's under these circumstances, but I'm happy to see that it's coming forward in the public's knowledge, and people may start to be a little more aware of this. Another thing that popped into my mind as Ken was talking, we install ERVs in our buildings and we give the client no control of them. So what that means is we don't put a switch to turn the ERV off anywhere. And the reason for that is I've heard too many horror stories and I've seen it firsthand. You install it, They move in and they go, hey, that thing's making a humming noise. Let me shut that off. That probably shouldn't be running all the time. Obviously, that goes into our client education piece. But I don't want them to be able to turn that thing off or turn that thing down. What we do give them is boost switches so that they can ramp up the function of the system. And this kind of goes with your statement about IAQ is for people, moisture management is for the building. You know, everybody knows that old trope that, you know, houses need to breathe. Houses don't need to breathe. People need to breathe. Houses need to dry.
So let me talk real quick about, so that's always been a challenge, right? Do we allow the occupant to turn or defeat the system? And I've always argued that if they buy the house, they get control of the house. If it's non-owner occupied, they get no control. And my rentals, my occupants get no control of the moisture sensing fans. They get no control of anything, quite frankly, as far as that's concerned. However, we do in the Northwest and in the Southwest and a lot of areas, my guys in Alaska in particular, we have issues with wildfires, right? So one of the challenges with wildfires, and when I talk to builders, I talk about the potential of putting supply air filter boxes in, because in the case of a wildfire smoke, as you know, all air is a liquid. Wildfire smoke is also a liquid. And in wildfire smoke is what they call isocyanates, right? Isocyanates, the way that works is it's just part of the smoke. When you see blue smoke coming out of there, it's the part that's unburned. And the isocyanates, when you breathe them in, they actually have a boiling point of about 74 degrees. So you breathe that into your 98.6 degree body and it vaporizes into the body, into the lungs. So it passes the alveoli that line your lungs and sinuses and nasal canals, which are the first defense against all viruses and bacteria. But because it's aerosolized as that and it doesn't vaporize until it gets into the lungs, that isocyanates will actually paralyze the lungs, which is, if you think about it, if you ever got a face full of campfire smoke and you get that little lightheaded, there's a carbon monoxide component to it, but also cyanates. Those cyanates will paralyze the lung and be problematic. So if you have, again, if you're compromised and you have forest fire smoke and you're injecting that into your house with an ERV, or even, you know, to some degree with exhaust only strategy, that can be problematic by itself. And I would love for everyone to have that conversation with their property owners as well. You know, if you live in an area where you're prone to wildfires, smoke is a problem, right? We have to be able to defend against that. And I love, and I bang this drum repeatedly with Panasonic to create a surface filter function for our ERVs, where I can put a 10 by 10 or a 12 by 12 surface filter. I can get a HEPA filter. I can get all sorts of different carbon filters that will help manage that. I've seen literally contractors who build curtain filter boxes for forest fire smoke situations, like in Fairbanks, Alaska and Anchorage, Alaska. There'll be 3 feet long with curtain filters in there, and then they'll use an inline fan to drive air into the curtain filter, and then they use the ERV, HRV to pull that air throughout the house. And without that, your house is going to smell like a barbecue for the next 6 months. I mean, it's you know, forest fire smoke is going to sit with you for quite a while if it gets inside and picks up into your clothes, into your furniture, into your carpets, or whatever you might have. So there's all sorts of these little crazy challenges out there that we have to try to figure out to address without sacrificing, you know, the occupant and trying to make a better footprint. Oh, let me talk one more quick thing about something Bryan said about here in the Northwest, where our moisture, we get a lot of moisture outside. There's no question about that. However, nationally, across the US, and I don't care what latitude or longitude you live at, the bigger issue with moisture is always going to be the occupant load, right? Occupants per square foot. And while, you know, Bryan's got these beautiful houses and they all have a great system, I work with a boatload of properties where they have a horrible system or no system at all. And moisture comes from the inside, right? So moisture is that human component, that living component. And, you know, as I said earlier, moisture simply looks for a place to condensate. It just wants to go home, back to a solid surface, turn back to a liquid, run down your wall, or whatever. It just goes from a high pressure system to a low pressure system looks for balance. And people always ask me, well, how fast will moisture move through your house? And my favorite answer is the smell of coffee. How long does it take the smell of coffee to go from your kitchen throughout your entire house, right? Because that smell of coffee is moving on a vapor path, and it's going from a high load where you're boiling water to make your coffee to a low load where everywhere else in your house. So the smell of coffee, if you want to think about how fast it moves throughout your house, how long does it take the smell of coffee to move from one end to the other?
So guys, we've got quite a bit of questions that were piling up in the chat box. The gist of a few of them is based on choices, like ERVs and HRVs. Depending on where you live or what the conditions are, how would you decide what you want? And also, just generally, how do you find a person in your area who's knowledgeable enough to advise you on what sort of ventilation system you need if you don't know yourself?
I can at least jumpstart the conversation. Again, just to emphasize, this isn't a Panasonic ad. Even though it kind of sounds like it, the fact is they've got a suite of products that's easy for us to use. And if we can use repeatable products with the same mechanical contractor, other than making sure that louvers are open, it is so much more efficient than for us to bounce around. So we use the IntelliBalance 100, and they've got a cold climate version. I'm telling you what, I've asked a lot of people about this. I've done a lot of thinking. It seems that the current party line is you kind of can't go wrong, and I'm probably going to be wrong for like Alaska or something, with an ERV. The IntelliBalance has a cold climate version. We don't need the cold climate version here. So I think if you look at their map in the contiguous United States, you're probably okay with that. And then I'll just let somebody else answer and modify everything I just said.
Well, let me just touch real quick on that ERV and the IntelliBalance. And I love the IntelliBalance, and I'm truly biased, so don't think anything different. But I had that tested by Cold Climate Housing Research Center in Fairbanks. And the thing about ERVs, historically, they've always been afraid of that core is going to freeze up, right? And there is a potential for the core to be problematic if you try to exhaust from the bathroom. Oh, that's one other thing I wanted to touch on. The reason we don't exhaust from bathrooms and utility rooms, it's not because of anything that the homeowner has a problem with. It's because first of all, it's just a very insignificant filter that takes the dust and moisture out. So when it gets into that core, if I add dust and moisture into the core and someone turns that off, now all of a sudden I've got a chia pet, right? That core. So if you get a dirty filter, the homeowner solves that problem. But if the core fails, they call me. And the core is a couple of $100 for me to fix. So we don't like you putting extra water and extra dirt. And that, by the way, that laundry room is the most dusty room in your house. And that's all organic material coming off your cotton and clothing and stuff. And you're shoving that in there with moisture, and nothing good will ever come from that in that core area. So the ERV, one of the things that we do ask for in our instructions is that you put it inside the envelope, right? So at cold climate housing, it was inside the envelope. And even when it was minus, I think it was like minus 25, and I have this in a white paper, by the way, even when it was a minus 25 degrees outside, the dampers never closed, the cold temperature dampers. And there's a thermostat, thermistor right inside the supply air damper. Remember, it has to freeze at the device for it to be a problem, not along the line. So temperature of the ambient air around it before it got to the device would take the edge off that minus whatever it was, 25 degrees. I think there was only 1 or 2 times during the whole time that damper actually closed. And then even when it does, it becomes an exhaust only strategy and it continues to work. It's not going to leave you hanging, so to speak. So I'm never afraid of temperature with ERVs. I'm never afraid of moisture because the ERV is always going to balance. The only thing that I have fear of is if you shut it off, right? If you are trying to exhaust a bathroom and you pull all that moisture out of the bathroom, put it into the core, and then turn the ERV off, then that moisture is going to sit and it's going to condensate and it's going to start dribbling out the bottom. That's a problem. As long as the unit is on, that airflow is self-cleaning. It just balances humidity inside to out. So would I use it in the north? Absolutely. Because in the north, in the wintertime, I want to hold on to the moisture in the house to some degree, so I don't wind up drying out those natural timbers and so forth. And that can be a little frightening, you know, when you see these big timbers start to go pop in the middle of the night. It's like you're under gunfire, for crying out loud. So, and then in the summertime in a hot humidity, it's going to exhaust that out. Plus, if you have air conditioning, the air conditioning itself is also a dehumidifying strategy. So I don't know any place, you know, I guess maybe in Southern Florida where I might have, you know, 350 days of really wet air. You could do the HRV along with your, but quite frankly, I would probably treat my supply air first. I would just do a raw treatment on the supply air for a dehumidification strategy. And I could still use an ERV and never have to do an extra condensate line.
So something I can chime in and mention here that kind of dovetails with what Ken's talking about, and I'm totally in agreement. You know, for a long time, people push back about using ERVs in cold climates. I've always been a believer in them, and we've never seen any issues. There's two ways that some ERV systems can deal with that frost potential in the core. So like Ken was talking about, what the risk is that we have humidity coming from inside the building through the core, and then we have really cold air coming from outside, and it can actually freeze inside the core. So there's two processes generally that we see. One is like a recirculation mode, like the IntelliBalance uses, where it shuts off that supply coming from outside and just recirculates air through it, or just continually goes to exhaust only, depending on what the system is. The other is some of the units use a preheater for the incoming airflow. There is an energy penalty associated with that, because obviously you have to use a fair bit of electricity to preheat the airflow coming through, but you can deal with it that way. And just like Ken said, really my only concern area is like a zone 1, zone 2 super humid climate, Houston, something like that. I might be a little hesitant to put an ERV in, but for me,
added dehumidification for certain.
Yeah, exactly. Doing like a ducted dehumidification system, like a thermistor unit or something like that on the incoming airflow is smart in those scenarios. Something else that I wanted to talk about, since we're discussing IAQ here, is Merv ratings on filters. I won't install anything less than a Merv 11 in any of our projects. And that comes out of, I had the ability to sit in a conference with Terry Brennan, who works for, I can't remember if it's NREL or Oak Ridge National Laboratory, studying these things. And he said that essentially anything below a Merv 11 is not filtering out the particulate sizes that are of health concern to the human lung. And Ken, by all means, correct me if I'm wrong here, but Merv 11 is kind of our lowest threshold for safety. And I know the IntelliBalance units, also, like Bryan said, I don't want this to come off as a commercial for Panasonic, but Panasonic hands down has some of the best options to price for products when it comes to ventilation. We use strictly Panasonic bath fans in all of our projects. We have used the IntelliBalances on projects in the past. The other one that we use quite a bit is Zender, but the project has to be of a certain size and budget in order to afford doing a Zender unit. The Panasonics, you really can't go wrong with anything across the board from them. And I know that the IntelliBalance, because when I installed them, I spec'd the Merv 11 filters that you guys offer. I don't think it ships with Merv 11s, but there's Merv 11 options. So
well, it's Merv 13, I think, is what it's.
Or Merv 13.
The optional one. Merv 8 is what's coming in.
Yeah.
And that's kind of a challenge for us, right? Because the 99% of the world is covered by Merv 8. Merv 8 is the code. So we have to build it to the code. I could build it to the Merv 13, and I could only sell it in California. So, because they require Merv 13. So we have to be sensitive to the marketplace to some degree. And I honestly, I am a huge advocate for that, for doing a filter box, because I can take that Merv 13 or a HEPA filter that's a 10 by 10, and I can actually reduce the friction of the airflow, or static pressure, if you will, going into the fan and make the whole thing even more efficient by putting that filter box with a 10 by 10 or a 12 by 12 that I can go buy at Home Depot, or I can, for heaven's sakes, here, I could buy it at Safeway, for crying out loud, right?
Or
So
stepping up to a thicker cartridge Merv filter, because that's
that,
something I don't know if everybody's aware of, is so you can go higher in the Merv level, but if you're not making the filter cartridge itself thicker, you're generating more static pressure and restricting the flow of the system. So if you're stepping up, like on our projects, we're doing Merv 11, Merv 13 return filters on our ducted units. We make sure that we install a box for that return filter that can accommodate up to a 2-inch thick filter, because you want that thickness of filter to give you the filtration without creating so much restriction that you're losing airflow.
the other thing that I talk about, and I've since, so part of my many things that I'm doing, I edited all of our instructions. And our instructions, it talks about that IntelliBalance has a 90-day chime that says, and in the instructions, which was written by Chinese and Japanese and converted to English, it says you should change the filter every 90 days. And I am not a proponent of changing the filter every 90 days. I'm a proponent of changing a filter when it's dirty, right? So I've since modified that I want you to inspect the filter every 90 days. You can vacuum it out a little bit if it's got dust or bugs in it, and then replace the filter if it's dirty. So we inspect, we clean, and we replace. You don't have to go out and buy a filter every 90 days. That's kind of a misnomer, and people get afraid of that, because now all of a sudden, if you have a unique filter situation, you could wind up spending a lot of money buying filters, and I don't want that to be the thing that stops someone from embracing a good system.
I generally advise our clients to do it every 6 months, and actually at the completion of projects, I make sure that there's a full set of filters for whatever is used in the house, and I'll set up Google Calendar alerts for them to chime for every 6 months for the next 2 years to kind of get them in the habit of going through that.
The issue with that, though, is that, and again, I talk about this all the time, here in the Northwest, we have pollen days, right? So you could change your filter on Monday and have the wind come through on a fir tree pollen day, and the next day your filter's just yellow cake, right? So you may have to wait 90 days or 5.5 months for this to be looked at. So, and I've been haranguing Panasonic to put so if we set up, if you set up your ERV to run at 50 CFM with our ECM motors, I can tell you by RPM when the static pressure changes, right? The RPM will tell me that the static pressure has changed, because now I'm pushing harder against that. And I'm trying to give them to give us an RPM delta, so to speak, where if it moves by 15%, now I chime the filter, or it moves by whatever that number might be, so that we have a better approach to filter issues. It's hard to do. Panasonic's a big company. They move glacially fast.
So yeah. Ken, what about, I've seen some companies are coming out with washable pre-filters or filters, or is that something that could possibly work into this equation, or are they not really where they need to be?
Well, so first of all, a washable filter will never give you the Merv rating that we're talking about here for a Merv 11, Merv 13, or a HEPA type filter. All that does is keep the rocks, like the pollen perhaps, but even our filter in Fairbanks, we had the Merv 13 filter on there, and they sent me pictures of mosquitoes who had gone past, through, and around that Merv 13 filter, literally eating their way through that filter, and were stuck into the core, and we replaced the core. So yeah, you could put a screen on there, a bug screen, but I've literally had in Juneau, had them take the outdoor to supply air, and they peel a mat of bugs off the screen. So all of that is airflow restriction, right? And the beautiful thing about these ECM motors is they will spool up. They will solve that problem for you up until a certain point. So yeah, you could do that. Again, I tell people if they're putting that supply air filter box on there, they can take my factory filter and pull it out. My issue with our factory filter is every builder wants a smaller ERV package that gives them more efficiency. right? So we have to defeat the physics and magically give them, a bread box size ERV that's going to allow all this airflow through there, and at the same time do all that. So our filter is, I think it's 4 inches by 8 inches, and it's more expensive than I really would like it to be. So if you put a filter box in there and you can go get a 10 by 10 or a 12 by 12 from a local filter manufacturer, I am all over that, because you're more inclined to change the filter. And in the long run, it'll be easier on my device and it'll be better for the occupants.
Can I just jump in a little bit and kind of chime off of what you're talking about watching RPMs, the delta of RPMs for static pressure? This is just me pulling my nerdy crystal ball out here a little bit, and this is based off of some conversations I've had with other industry people in the ventilation world. I think where the industry's headed, and like Ken said, it's glacially slow, but it's headed in this direction, is that we're going to see more feedback loops in our ventilation systems. So we're going to see ventilation systems monitoring static pressure to tell us when we have an issue or when we need filter changes. We're going to see modules coming out that are watching VOCs and CO2 levels inside of the building to automatically control the ramp up and ramp down of the blower speeds. So essentially, also getting them to communicate, like you could have a bath fan and a range hood communicate through Bluetooth or Wi-Fi or whatever it is to say like, hey, the bath fan's not doing enough air movement right now. Let's kick on the range hood. I think we're going to see a lot more integration and monitoring in the ventilation realm as time moves forward. I wish we had it now, because it would solve a lot of these, little quirks that we have about when do you change a filter that we can't easily answer right now. So fingers crossed, my crystal ball is telling me that's where a lot of things are headed.
Yeah, even now we're working on and developing those. The rub with all of that, of course, is technology costs money. And so can I talk Bryan into spending an extra $2,000 to have his fan know that there's a low airflow in one room and have it turn the fan on? It's tough, man. Bryan's a tough sell. Once sold, he's great to go, but he's a tough sell, right? He's, at the end of the day, one of our responsibilities as manufacturers is to make sure our builders have the product at a price point that they can sell their house. If everything costs so much, and Washington State is becoming, as Bryan will tell you, problematic in that respect to some degree, but if it costs so much to build a house that you can't sell the house, who have we helped, right? It's a big challenge for all of us, right? We want to add intelligent products, but at the end of the day, I got to help Bryan sell his house. So if I can add value, I'm all over it. But if the value is not relative to the cost, it can be frustrating.
So, go ahead. I was going to say, so speaking to cost, I mean, Ben, you listed earlier the different levels of choices people have in systems. And obviously there's going to be people out there who aren't going to spring for the ideal system for the house that they're working in. And, some people will tap into their heating systems to try to borrow some of the ductwork. I mean, can you talk about if someone does make compromises like that, what are the things you have to worry about? Like, you have back venting or any that sort of thing? Are there components you can add to a system to make something like that work? Or if you don't have a balanced system, like how do you deal with getting the air to parts of the house like the bedrooms?
To steal a great line from Christine Williamson, it depends. It really is, it's case by case, and going through all the little nuances that can affect the overall success of a system. We don't have enough time here. So it's kind of, I think that's part of the reason why I nerd out so much on ventilation, because there are so many factors that affect it and so many project-specific situations that affect what we choose and how we install a system. To talk a little bit to your mention of cost, you could do like one of the Whisper Select fans from Panasonic and set it up with an ASHRAE 62.2 module, which I think costs you like an additional $20 or something like that to add on to an already existing bath fan. So that's a cheap strategy. That's like foot in the door. It's better than nothing. You're doing the right thing. you know, I think the Whisper Comfort Select or IntelliBalance 100, forgive me, is what, about $1,000 or something like that, signed, sealed, delivered, plus installation costs. So you're looking, depending on how complex you go with the ducting and distribution on the system, a few $1,000s to get a system in. And then you step up to kind of the top end of the realm, going to Zenders, which come with, you know, a completely engineered, designed system with all the ducting included, everything, and a factory tech that comes and commissions the system for your project. Those are running $7,000 to $9,000 plus install. So it can get expensive, but there's also expensive side effects if you go cheap sometimes.
Sure.
Get in there, Bryan.
Yeah, I think at least what my approach has been is to take one thing at a time and try to learn as much as you can about that particular thing. And over time, you start getting more tools in your toolbox, more solutions to a problem at hand. It's not just about ventilation. You know, you walk away from a conversation like this thinking, oh man, I got to figure all of this stuff out. Well, it's just a component. Again, I'm much more interested in the structure and making sure that the house is built stoutly and that it can withstand the loads. That's what I learned first. And then over time, I've learned these types of things. But the house still has to look good. So you have to think in terms of what are the finishes like? What's the exterior cladding? There are so many factors that go into it that I could imagine it would be overwhelming if we tried to figure out, if we tried to become an expert in every element of construction on our very first home. But just take one thing at a time, and I don't think it gets quite so overwhelming. But then over time, you've got the experience to draw from. Oh, I remember I used this solution here that I can apply here. But to speak to Ben's point, it is not going to be the same solution on every single house by any means.
So there is no one size fits all. I mean, everybody has to actually go through the details to get it right. And that's, to me, that's one of the things that's so challenging about this, and why it's so great to have resources like Ben and Bryan and Ken. I mean, Ben's done a great job of sharing the Zender installs that he's been doing in the past, and a lot of other topics, but especially on indoor air quality. Bryan's been posting building science stuff. I mean, everyone's doing a great job of trying to share what they know, and I think that's moving us in the right direction. But to Ken Nelson's point earlier, I think it was Ken, the entry point doesn't have to be the tens of thousands. The entry point can be in the hundreds, like bringing up the bottom of, you know, the code built minimum house that everyone's vilifying these days can be just slightly better for, like Ben Bogie was saying, you know, a few $100, do a little better, just do a little better on this one. And when your client's happy with you and you saved money on your warranty because you didn't have moldy bathrooms or, you know, sick clients that don't recommend you, then throw that money into your next one and just keep getting a little better. That's kind of what we're all trying to do here, I think. I mean, there are guys out there that are shooting for the moon, that are really, you know, they're showing off, and that's great because that gives us something to aspire to. And their clients are better off for it. They're living in a house that has amazing air quality, and they're probably healthy and happy and recommending those guys. So everybody wins there too. But the idea of making your starting point the operating room of houses, it's not necessarily realistic or beneficial. So that's really what inspired me to reach out to Bryan in the first place. I was like, this is a great strategy. I read how to do this. I think I can do this now. So I really appreciate you guys giving us your time and talking through all these details. It's just so daunting when you don't know what you don't know, to have the resources that you guys are providing, and then certainly to be able to reach out to you directly through Instagram or whatever is a better. I don't know what's a good way to get a hold of you, Ken. I mean, we've got 80 other people on here that are going to be going, hey, I need to call Ken Nelson. I have a question about my house and I want to do this right, but I don't want to mess it up. and I want to do it cheap too, and he's already talking my language. What's a good way to start these design conversations? Is this something you expect a regular builder to actually get a mechanical plan? I mean, gosh, I haven't seen one of those yet. I've been in this business a long time.
No, I don't think you need a mechanical plan. I think you just, really, it comes down to you have to want to build a better valued product. And I'm not saying a more expensive, but a better valued product. I'm pretty easy to get hold of. You can go to panasonic.com/vent fans. You can go to our webpage. Or, at Panasonic, our email address are ken.nelson@us.panasonic.com. And Travis, you certainly have all my contact information, and feel free to hand it out like you would my card at a bar. So,
I'll write it on the restroom wall for a good time. Yeah. For good air quality, call Ken Nelson.
Yeah. So, and there's a number of publications that you can see where I've published some stuff, and of course I can't think of any of them right now, but there's I'm out there. You just call, if you call Panasonic Ventilation and ask any question like how to spell ERV, it's going to come to me. So it's frightening sometimes how much stuff I get.
If I could, Travis, Rob asked the question earlier, how do you find a builder who knows this stuff? I think right now we're still in such a nascent phase with all of this. A lot of guys are super accessible. Personally, I get DMs probably every week asking for a consultation of some sort on, I just had one from a gentleman, he's a historical renovator in Olympia, Washington. I ask people questions all the time. I talked to Steve Basic this morning. He gave me Peter Yost's number. I don't know how happy Peter was about that, but I texted him, and Pete texted me his email address. I've got some questions because I think something we may be running into is unoccupied buildings during the COVID pandemic. We've got schools, we've got churches. In Florida, are we maintaining our set points where they should be? If we're in upper Michigan and we're coming into the heating season, are we maintaining the set points where they should be if they're unoccupied? So there's things online about relative humidity. I've been in an article from 2002 from Joe Stiebrick. I've been Googling all over the place. I don't have the knowledge. I can read a psychrometric chart, but I don't think it's all out there in a really nice, concise place to answer the questions I have. Guess what? We've never had, maybe thousands, hundreds of thousands of unoccupied buildings. It's crazy. This pandemic is making me think of something new, and I haven't found a good, concise place to get that resource. So I'm barking up different trees. I've been DMing Mike Gerton about it. Mac Architecture, I can't think of his first name right now, Kyle. So, the industry is still small enough that I think everybody has enough time to help each other out to try to solve some of these problems.
You can DM me and I'll gladly send you an invoice at the end of it. Just kidding.
I'm embarrassed to ask, DM?
Direct message.
Direct message. Oh.
Direct message. Yeah. It's what all the kids are saying these days, Ken.
Oh, sorry about that. Well, my kids are long gone, man. So it's
you don't have the in-house support.
Yeah, exactly.
Something I want to take off of what Travis was saying is this is daunting. There is a ton of information. You're not going to get it overnight, but doing something is better than doing nothing, even if it's the cheap option. So start with whatever works, whatever you're comfortable with, whatever fits for your client, for your project, and just start somewhere. And that's, you don't know until you try.
So if I'm going to leave with one thing I want relative to the COVID deal, and that's to all of our customers that we talk to, make sure they understand the difference between ventilation and circulation, right? One of the things I run into all the time is people think circulation is the same, and it's not. So recirculating the same air you're breathing is not resolving or diluting any of these viral particulates. Ventilation is indoor air being exchanged with fresh outdoor air. And that's a message that I think we're kind of all should take a little bit of responsibility for, to try to get out in our conversations, to make sure that whomever we're talking to understands that ventilation is not the same as circulation.
Well said.
And you know what, you guys keep talking about the direct messaging or just watching each other and learning from each other. I mean, it seems like Instagram of all the social mediums is the place where a lot of that is happening. You don't necessarily have to even reach out to anybody. If you just follow and hang out with the right people, you're going to see people sharing lessons about this every day. And maybe over time, it's a lot easier to sort of absorb all of that information rather than trying to read a whole textbook on it all at once.
That's a great point, Rob. There's a lot of great podcasts in addition to what's on Instagram. There's YouTube. I know a lot of people are big fans of screens. So if you're a YouTube guy, I learned a lot from Matt Reisinger early on. The stuff that he was putting out there really helped bring me into the fold. My local contractors licensing classes, I took a great one from Marco Liberté, who teaches at Construction Instruction. That gave me great access. Went out there and saw Justin and those guys do an amazing job. I know that my local contractors class, Neil Ezel, who's on this chat tonight, gave me a fantastic bit of building science. So there's a ton of stuff out there. And obviously you would want to read Fine Home Building and subscribe to Green Building Advisor. And you can chase this stuff down. But the reoccurring theme here is the information's out there, like what Ben said, get in the mix, try to do a little better every day. Every build, you get a little better. And I think we're all moving in the right direction. I'm really grateful to you guys. I know that we're kind of running up toward the end of our time, and I don't want to put a bow on it for everyone. But if we have time to do a last round of comments from everyone, I know Ken and Ben kind of started that already. I want to make sure everyone gets in the mix before we go.
I'll share an expression. There's another building science podcast that I accidentally found. He doesn't do much with it anymore, but it was because of Matt Reisinger having Christoph on his show. And so I Googled building science podcast or something. And maybe when somebody else is talking, I'll pull it up on my phone and not waste everybody's time. But he always would end with a quote. Or most of the time. Anyway, one of them was, if a human can do it, so can you. And man, I just absolutely love that because, first of all, it's not exactly true. I'm just not smart enough to be an astrophysicist. But in general, the stuff that we're dealing with in construction, almost anybody has an IQ to be able to do it. I think when there's something that's unknown, or something we haven't done before, we just naturally as humans have a fear, a nervousness, and anxiety about it. But if you just do and I'm just reiterating what everybody said, just do a little bit, just do something. And if each one of those little bits of knowledge is viewed as a brick, over time, you're gonna have a house of knowledge. But if you never start laying the bricks, you're never gonna get a brick house. So that would be my sign off, and I'll look up that podcast.
The Building Science podcast is a phenomenal one. Just to kind of rattle off some of the places where I've absorbed a lot of info. Building Science podcast, the Building Performance podcast. Let's see, IAQ Radio Plus. That one really gets into the weeds on stuff and can be a little bit of a slog to get through, but there's some really great stuff in there. HVAC School podcast, Building Envelope, or Everything Building Envelope, ICC Consultants podcast, Buildings and Beyond podcast. That's not all IAQ and ventilation, but that's Stephen Winters Associates, who operate out of the New York metro area and do some really kind of cutting edge building science work. And then the Building HVAC Science podcast. Those are great resources. There is so much information in all of those. Obviously, GBA, Stebrick sites, go on to Oak Ridge National Laboratory, the Building America programs. there's a tremendous amount of this stuff out there, and it takes time to get through it. But honestly, the way I've absorbed a lot of this stuff is I'll take one of those podcasts, and while I'm doing trim or something like that, I throw it on in the headset, and I might not get all of it, but slowly it's just kind of filtered in and kind of reaffirms some stuff or turns me on to new things. So just think about it, try it, do it. Like I said before, doing something is better than doing nothing.
For me, I just wanted to say thank you guys for having me and letting me kind of spout off a little bit. I've thrown my email address on the chat board, so if you have any questions and you don't want to go through Travis, you can send something directly to me. And I appreciate you having me. Thank you.
Well, with that, we've kind of gone around the horn. I will just thank everyone once again for joining, obviously our panelists, but also our guests. The folks that are in the chat, they're doing the right thing, trying to educate themselves, and honestly, there's a lot of stuff in there that's educating me. So I thank you guys for that. Come back and visit us next month. I think we're going to get Neil Ezel from Ezel Morgan Builders in Lawrence. I think we're going to try and do it live. We're doing it live. Bill O'Reilly beam there. So if you guys want to come and visit with us in Lawrence, Kansas, come and see us. Neil's going to talk, right, Neil? Anyway. Thanks, Rob, for everything, running the show. I really appreciate everything you guys do to support this movement. And, of course, Ben, Ken, and Bryan, you guys are awesome tonight. We could do this for another 2 hours, and we'd never run out of questions. Thanks so much.
Thank you. Take care, guys.
Take care, everybody.